procedures for particularly for discontinuous. Then some troubleshooting of common machines and process problems and remedies. From number 7, we will cover on continuous PU panel line, configuration of dry part and wet part, machines and equipment involved in continuous line, process flow line, process flow of this continuous line, and then some innovative technologies in multi-component pre-mixing unit for mixing of multiple chemicals simultaneously for this continuous line, and then troubleshooting of common machine and process problems and remedies. And after that, we will have 10 minutes of question and answer session. So first thing regarding the introduction of PU panels. So most of you, I think you are already aware about the PU panels because most of the people audience here coming from the this industry. So to start from the basics, like the types of PU panel manufacturing processes currently, it's discontinuous PU panel and continuous PU panel. So discontinuous is some people also call discrete. So some people call it batch type production as well. So, so what are the disadvantages and advantages for discontinuous line? So as you can see here, discontinuous line is, if we start about the advantages, is less investment required because there are number of equipments are quite less compared to continuous line. So initial investment is less, less space required. If you talk about largest discontinuous line in terms of length, this is 12.5 meter. So altogether lengthwise, it will take about 45 to 50 meter length, and width-wise is about 20 meter. So this much is roughly space required. Compared to continuous line, this space is comparatively quite less. Installation period is faster. Then you can relocate this discontinuous line easily. This is good for odd size panel production. When we say odd size, meaning that you can produce a smaller length. A longer length depends on the platen size what you have, but you can produce odd size width. That is the major advantage of discontinuous line. Can produce small batch of production. So you can produce 50 meters, 100 meters, 100 square meters. It's not like in a continuous line. Continuous line, you have to have a sizable batch of the production to start the line. Can produce different thicknesses easily. Just you have to change the side molds and you can change the thickness. Can produce wide width of panel. As I mentioned, you can produce up to 3 meters of panels in terms of width, provided the press or platen sizes are capable for that. Disadvantages wise, slower production rate is major disadvantage. Higher manpower required because a lot of processes are all manual. So the manpower requirement for this discontinuous lines is higher. Higher manual handling resulting panel quality issues. This is one of the major drawback also. If you compare the quality of the PV panels in terms of discontinuous versus continuous, discontinuous have more chances of poor quality in terms of handling. So dents and scratches, the chances are more. A limitation to produce PIR panels, soft skin panels, and rock wool panels. Limitations are there, but still some companies they are producing PIR panels in discontinuous. They have some different processes, different chemicals, but it's not easy. The next is need high output PU machine for higher thickness and length. This is since you have to pour into the closed cavity, so the PU machine output has to be higher capacity to produce higher thickness panel. So these are some advantages and disadvantages of discontinuous line. So next slide is continuous line. Advantages and disadvantages on that. So if you start from the advantages. So first advantage is very high production rate. So yearly can produce 1.2 million square meters. So this is again depends on the average thickness. So usually when we say 1.2 million, so this is based on the average thickness of around 50 mm thickness. Again, the configuration also is depends. So what double melt size you have, length you have. So based on that, the capacity on yearly wise can be defined. Less manpower required. Then manual handling is less, so better panel quality. Of course, the process is fully automized, so the panel quality compared to discontinuous is quite much better. Better foam quality due to open type foam spraying and multi-component wet part use. So you can control the process easily. So the foam quality is much better. Can produce all types of panels like a steel facing, flexible facing, rock wools. So these are the advantages. In terms of disadvantages, like high initial investment. So this is one of the disadvantage. If you compare approximately the prices discontinuous versus continuous line investment is at least around 3 to 4 times higher compared to discontinuous. Larger factory space required, then longer machine delivery time and installation time. Machine delivery and installation, the project total time, it takes sometimes about 1 year. Whereas in discontinuous, you can set up the whole line within about 3 to 4 months. Need bigger production batch and can't produce wide width of panels. So these are the some limitations and disadvantages. The next slide is about machines and equipment involved in discontinuous line. So briefly, you can see here roll forming units, hydraulic press, and PU forming machines. These are the main primary machines involved in discontinuous line. Of course, there are some other equipments as well, like corner presses or sheet metal bending machines and all. But majority is these are the three machines required. So for press size, the hydraulic presses, there are different types of press in terms of length, width, the process wise. So as you can see here, the discontinuous moving platen type presses are comes in 1+1 size, 2+2, and 2+0. This is talking about the number of platens, but again the sizes wise, the press can come in different size like a 4.5 meter, 6.5 meter, 8.5, 9.5, up to 12.5. So width wise also 1.5 meter width is standard, but you can have a different customized widths also. So apart from moving platen press, there is another type of press is multi-daylight. So these presses are good for producing smaller length panels, especially for AHU or for clean rooms. Then there is a 3+3 moving platen press. This is a new kind of press which is having 3 platens or 3 daylights, we can say. But the limitation is you can produce a smaller length panel, and this press is typically good for AHU or clean room panels. And then fourth type is corner presses. So for those cold storage panel, people use this corner press to produce corner panels. Regarding the PU foaming machine, so you can see here high pressure machine, which is a standard non-compatible for pentane. Then second type is pentane compatible high pressure machine. And then there is some secondary equipments as well, like cyclopentane plus polyol premixing system. Of course, there is another machine, low pressure, but nowadays no one wants to use the low pressure machine for producing PU panel because of there are some major disadvantages. So that's why this low pressure machine I'm not covering here. There is another process called three component process for discontinuous line, or rather three component machine. So here actually, apart from iso and polyol, only two component, the polyol is being premixed with the blowing agent at site or at factory. So that's what becomes three component, cyclopentane plus polyol plus iso. So here you can see some equipments with some flow chart. So there is a polyol storage tanks, then polyol comes from the drum to the storage tank, then cyclopentane comes in the drum, and either we can transfer from drum directly to the premixing or through the day tank. So here in the premixing system, the polyol and cyclopentane blowing agent get mixed. Not necessarily be only cyclopentane, there are different blowing agents as well. Though these bluing agents get mixed into the pre-mixing system and then transferred to the PU machine's polyol tank. ISO is directly loaded into the ISO tank and onto the PU machine, and from there the chemical goes to the mixing gate, and then there is a pouring. So this is a 3-component machine for discontinuous line. So some innovations in discontinuous line. So you can see here 3+3 press is the one of the innovative technology we can say. With this press, you can have some space saving because we are using vertical space. So that's why the production efficiency also increased by 30% because you get the multiple platons. So if you compare it to the 1+1, you have now 3+3, meaning that at a time you have 3 platons in the preparation and 3 platons in the production or foaming. So the production efficiency is increasing by 30%. Okay, so that was about the 3+3 press. The next slide is about tilting press. So as if many of the people you might know that in discontinuous panel, there is an issue of having the air entrapment. So to avoid this, the whole press is can be tilted. So this is also one of the designs. So there is a tilting press being supplied. The next we can say the development or improvements is instead of using the hollow platons, there is a solid platons. So solid platons give you the advantage of a better temperature distribution. So since the water is directly circulated through the platon, it can have the faster achievement of the temperature. And this is good for producing PIR panels because for PIR panels, you have to increase the temperature of the platon up to around 55 to 60 degree. So with these solid platons, you can achieve that temperature easily. Just I'm checking. So I'm audible, right?
Yes, sir, you're audible.
Okay, yeah. So moving on to the next slide is about machine operations. So regarding the discontinuous line like a press operations or PU foaming machines operation. So safety is paramount. Safety has to be first. So operator has to wear all the PPEs. So just a brief introduction or brief explanation about the machine operations, like starting from chemical loading. So chemical has to load into the PU machine's day tank. So it depends on the configuration or how many machines there in the factory. If you have the multiple machines, then the chemicals usually there are some storage tanks and the chemical is being loaded into the foaming machines day tanks automatically through the pipeline. But if it is 1 or 2 machines there, then people are loading it manually. So the chemical has to load, level has to maintain into the tank before you start your operations. The tank pressure is one of the important. So tank has to pressurize by around 2 to 3 bar. Then the daily cleaning of the self-cleaning filter. The next is you have to check the flow rate. So there are mechanically flow rates also you can set or you can set through the frequency drives. The chemical temperature is one of the important process parameter. So you have to maintain the chemical temperature. This is based on what your chemical supply is asking. Then you have to do the recirculation and check the chemical pressure. You have to set the pressure based on the process. Like isopolyol, you have to adjust the nozzle and you have to set the pressure. Check the flow rate during the recirculation. Then based on your production requirement or based on your panel requirement, you have to set the pouring timer or the production the PU foam volume. Then before you just do the injection, you have to do the mixing gate cleaning, and your machine is now ready for the foaming. In terms of dry part, like a press wise, you have to prepare the metal sheets onto the platen. Of course, before that, you have to do the roll forming according to your sizes, side profiles. Then the platen will go into the press. Here the injection will happen. Once the injection is foaming is done, then the platen will go up and it will happen the pressing. So after your pouring is finished, then the press will go for curing. So depends on your panel thicknesses. There are preset pouring, the curing timers are there. So after that, the press usually have the tower light, which indicates that the curing time is over and now you can declamp the press. So once you do the declamping, then the platen will come out and you are able to, you're ready to move your finished product, or we can say the formed panel. Moving on to the next slides, some of the process or machine problems and what are the remedies in this continuous line. So as you can see, like these are the common problems in the machines, process problems. Like sometimes this happens that there is no suction pressure at the pump. So you have to check what is the tank pressure you set, whether tank pressure is set properly or your compressor is running or not. Because if there is no proper tank pressure available, then the chemical will not flow to the pump and the pump will have the abnormal sounds. Also, you have to check the self-cleaning filter or basket filter. If filter is clogged, then also there will be less or no suction pressure at the pump. Metering pump making abnormal sound. This is also related to tank pressure. Just now, as I mentioned on the first point. So tank pressure and the filter have to check. Polyol viscosity also has to check, because if it is too high viscous polyol, then also pump can make abnormal sound. This happens especially in ISO filter frequent clogging. This issue people faced very frequently. And one of the primary reason is that the air which is being used or pressurized in the tank is having some moisture constant. So the dry air has to use. If you can use the nitrogen, that is the best. Chemical temperature not reached to desired level. So chiller capacity or chiller has to check whether it's working properly. If you're using machine for quite prolonged period, then you have to periodically flush out the tank jacket using some descaling chemicals. Then your temperature controller also has to check. Variation in the component ratio. So this is isopolyol ratio sometimes is not set properly, or whenever you do the pouring or injection, you see there is the quality problem in the foam. So for that, if someone is badly or wrongly adjusted the pump's mechanical output, then you have to adjust it correctly. If the machine is equipped with the frequency drive, then you have to see what is the frequency set for each pump, or the pump is having some malfunction. Isopolyol overpressure. This is mainly related to the nozzle. Either nozzle is faulty or nozzle is having some dirt. So nozzle has to clean. The polyol viscosity has to check, and you have to use the correct size nozzle. Isopolyol pressure not stable. Again, is related to the nozzle size or dirt in the nozzle. Also, the flow meter you have to check. Turbulent flow while injection. So this is mainly related to the machine capacity, machine size, or mixing head model, and what output you are set, and is it on the very much higher side? What type of mixing head also being used? So this has to check and correct accordingly. Some of the process problems like panel is underfilled. So if it is this problem happens, the mainly is has to check the PU machine output capacity. If you're producing a too big panel and the machine output is not capable for that, then definitely you will have this issue. Have to increase the air vent holes, then check chemical crimp time versus pouring time. Press platen temperature not reach. So this is mainly related to the water boiler system being used. So sometimes the water boiler is quite under capacity, or the heating elements are not is spoiled or not working properly, or there is a perforation happens in the circulation pipes. This has to check because there are internally water leaks, and then the temperature distribution is not proper. Uneven lifting of platens, which usually reflect into the panel's waviness, or there are some bulging happen sometimes. So this is mainly because of the press hydraulic cylinders is not lifting the platen equally. So the press cylinder has to check, especially for the seals and all, whether the cylinder is having some abnormality. There's a small video about the discontinuous line process. Okay, so this is just now is all about discontinuous process. So now we will move on to the continuous line. So this is a second type of PU panel manufacturing process. This is a just overall layout, as I can see, for the continuous line. So in terms of configuration of the continuous line, there are majorly two parts we involved. One is dry part and second is wet part. So for dry part, there are configurations which we are divided into three groups. The first group is basic configuration. So in basic configuration, you can see like a decoiler to cutting machine. So the DBL, or is a double wheel conveyor, can be 18-meter length. Then panel profile wise, like one wall panel, one roof panel. So this is a basic configuration. Medium configuration wise, decoiler to cutting machine. Then there's a stacking system, packing system. Uh, Double wheel conveyor can be 24-meter length. And panel profile wise, like two types of wall, one type of roof panel. Then high configuration wise, you can see from the decoiler to cutting machine plus cooling system, stacking system, and packing system. Double belt conveyor can be 30-meter length, and panel profiles wise, it can be two walls and one roof, or also it can be increased, depends on the end user's requirement. Then Rockwool panel comes into this configuration, and soft skin panel. So these are the mainly configurations for dry part. So those companies who are newly venturing into this panel manufacturing, so they can refer to this kind of configuration, and accordingly they can decide what configuration they wants to source. For the wet part configuration, so there is the first type is 2C system. 2C meaning that two component system. So iso and polyol. The machine is similar like a standard high pressure machine with the different mixing head. The polyol usually comes under as a pre-mixed. So the blowing agent is mixed into the polyol. It can be pentane, it can be other HFCs, new blowing agents. Then the next type is 4+1 system with the 4 component pre-mixing. So in 4+1 system like iso, polyol, blowing agent, catalyst 1, and the air nucleation system. The next type is 5+1 system. Here in the 5+1 system, the configuration wise like iso, polyol. Polyol of course is with the PUR and PIR, two kind of polyol. Blowing agent, then catalyst 1, catalyst 2, and the air booster or air nucleation. The next configuration is 6+1. So here actually more or less is same, but there is additional blowing agent. So instead of one blowing agent, there is another second blowing agent. So some of the companies who are majorly targeting panels for the cold storage and all, where the insulation value is very much important. So there they use second blowing agents as well. So this is the configuration for wet part. So the machines involved in this continuous line process. So there's a brief list and some photos for the wet part as well as dry part. So as you can see in wet part, like there is a high pressure PU machine, catalyst units, pentane blowing agent, then inline multi-component pre-mixing system, XYZ head mixing head carrier or crossbar system, safety panel with the gas sensor for a pentane safety, then the air booster for air nucleation, PIR glue primer. So those companies are producing PIR, so PIR glue primer is must. And some auxiliary storage tanks, including the underground storage tank for pentane. In terms of dry part, like starting from decoiler, then the filming and cutting device, the side trimming usually, roll forming machine, preheating system, double belt system, then the cutting system, cooling, stacking, and packing. So these are the mainly equipments for wet part and dry part. So this is in detail. So if you see for the dry part, the equipments involved in this process, starting from decoiler. So these are upper decoiler and lower decoiler for both the upper and lower sheets. So decoiler can have a single decoiler system or a double decoiler system. So those companies who wants to have a continuous production, especially the very high volume production, so they can opt for the double decoiler, which is having the sheet joining system. The next is protection film applicator. Then there is a Corona unit and sorry, side trimming, then Corona unit, then protection film applicator. Then next is roll forming. So roll forming again is for upper roll forming and low roll forming. Number of roll former units depends on your number of profiles and how many types of panels you have. So based on that, the roll former configuration changes. Then there's a preheating unit. Then there is a PRI glue primer. And then there is a XY mixing head carrier where the PU spray will happen. There is a multi-component wet part, which, as I mentioned just now, depends on the configuration. Like, is it 2-component, is it a 4-component or 5-component? After the pouring happens or spraying happens, the sheet goes to double belt conveyor. So double belt conveyor again depends on the configuration. Is it 18 meter, 24 meter, 30 meter? Cutting machine, then cooling system. There is a stacking unit after cooling, which stacks the panel, make the bunch, and then the stack goes to the packing machine or packing or wrapping machine. After that, the panels are ready for unloading or dispatch. So these are the mainly equipments involved for the continuous line. This is again same. This is just a process flow. just now, as I mentioned in the sequence only, like starting from decoiler, protection film, roll former, preheating conveyors, the foaming, then it goes to the double weld conveyor. Then after that, there is a cutting machine. Cutting machine cuts the panel based on your predefined length. Then the cooling system is required basically for higher thicknesses panel to cool down the panel before it goes to the wrapping. Then the stacker. After that, there is a packing machine. So different type of pouring or spraying methods. So as I can see, for this continuous line, when the PU spraying happens on the metal sheet, there is an oscillation poker, or some people they call is moving poker. Then there is a fixed poker. There are some old technologies like oscillation pipes as well, basically used into the especially soft skin or PU boards, and fix the multiple mixing heads. So these are the mainly four types of pouring or spraying methods. So when you talk about the new innovative technology for multi-component premixing, uh, there is a multi-component premixing system which mix up to 5 components or 5 chemicals together simultaneously before it delivers to the mixing gate. So this design actually helps to have the homogeneous mixing of all the components, especially polyol, cyclopen is N-pentane. So N-pentane and polyol, the miscibility is very poor. So uh, the special design actually it helps to mix the N-pentane with the polyol very homogeneously, and it's a simultaneously mixing of N-pentane, polyol, and catalyst. Of course, after the premixing, this is the first stage. Then the chemical goes through the high pressure heat exchanger, where also there are some internally static mixers available. So after the uh, production, these are the some finished products like a wall panel, cold room panel. Then there is a hidden fastener panel, soft skin, which also both side craft paper or both side aluminum foil. Then roof panels. I'll just play some one video regarding the continuous line process. Okay, so that was the whole process video for the continuous line. So the next slide is related to the typical layout of the line. So as you can see, the whole continuous line starting from the decoiler until the packing machine, it needs quite big space. So in terms of length, it depends on the again configuration. What is the double belts length? How many roll formers you have? Whether you are opting for the cooling conveyors and all. So the lengths it can go from 90 meters to 150 meters, depending on the configuration. Width wise, it can be like 15 meters to 25 meters. So this is typically required for the machinery only. So apart from that, you have to consider in the space for the raw material storage, space for the finished good storage. The possible reasons can be like improper mixing system, too low working pressure is related to the isopolyol pressure at the mixing head, improper use of mixing head model, high pressure, high losses of the pressure from pump to the mixing head, wrong size nozzles, chemical process temperature is improper, proker is clogged or worn out. So these are the possible reasons for having the poor mixing quality of the foam. So correction wise, you can see like mixing has to improve. So for that, of course, has to check into the PU machine size. What are the static mixer being used? What is the technology? Increase chemical working pressure. Um, Mixing head model has to check and has to choose accordingly to your flow rates. Pressure losses has to reduce. Then nozzle sizes has to check whether the nozzles is correct size is being used accordingly to the flow rate or the panel thickness. Nozzle has to clean periodically. Chemical temperature has to set accordingly to your chemical supplies recommendations. The poker has to clean if you're using moving poker and or if it is fixed poker, those disposable type, then that has to change based on your production frequency. Panel overfilled. This is also second one of the major issue. So if it is panel overfilled, then possible reasons are like line speed is too low, wrong recipe or wrong flow rate selected. Temperature at the double welt is too high. Pentane ratio set as too high. The moving poker is speed is wrong. So these are the possible reasons. So the remedies or corrections is like uh, since we know the reasons, of course, the remedies are quite easy. The line speed has to set according to the guide formulation. Flow rate has to set as also for the as per the guide formulation given by chemical suppliers. Double weld temperature has to lower down. The pentane output has to set as per the guide formulation again, and the moving poker oscillation speed has to also change. Panel underfilled. The possible reasons are like line speed is too high. This is totally opposite to the panel overfill, except some of the changes. The wrong flow rates or wrong recipe selected. The temperature at double weld is too low. The pentane ratio at too high. Or chemical reactivity is too fast. So these are the possible reasons. And the remedies are like line speed has to set as per the guide formulation. Flow rate also has to adjust according to the guide formulation. Double weld temperature has to adjust. Pentane output has to check whether it is set as per the guide formulation, density. The catalyst ratio has to adjust so that you can achieve the reactivity which is suitable for the getting the best result. Poor adhesion of the foam with the metal sheet. So this is also one of the problem. So you have to check the metal sheet surface and clean if it is necessary. There are some oil stains happens on the metal sheet. So you have to check the coil and the metal sheet quality. You have to use the Corona system. Corona system helps to improve the adhesion because it removes the static charges and also remove the dirt or oil stains onto the metal sheet. Have to check the preheating the temperature, whether if it is preheating temperature is too low, also is plays a part. Double weld temperature also check and has to adjust accordingly. The machine output has to set as per the guide formulation. And for PIR panels, you have to use the PIR glue primer, which helps to improve the adhesion. Stretch marks on the panel. So this is due to line speed synchronization between the roll former and double belt. Then synchronization between the upper and lower conveys also at the double belt. Panel side surface uneven. In this case, you have to check the side blocks locking is proper, and alignment of the side conveyor chain has to check. The next is some of the some of the machine problems in the continuous line. So starting from the chemical temperature not reached to the desired level. So this is similar like in discontinuous line is related to the chiller, to the heat exchangers. So this has to check. Metering pump making sound is again related to the tank pressure, the chemical viscosities. If your machine is equipped with the low pressure gear pump between the day tank and the metering pump, then this gear pump helps to deliver the chemical, even if it is slightly high viscosity, still is able to deliver to the metering pump. In this case, the pump's life also get longer, and this abnormal sounds or cavitation problems minimizes. ISO filter frequently clogging. So for that, you have to use the dry air, or if you can use the nitrogen, that is the best. Variation in the component ratio, again has to check the pump flow rates, the frequency settings, and the metering pumps, whether it's is in having any malfunction. Catalyst output not stable. So in this case, you have to check the pump output range and the specifications of the the pump, and whether it is meeting to the requirement of guide formulation. Poker clogging frequently. So this is related to the oscillation poker. So I have to change I have to check the poker model, whether it's currently correct model is being used for the as per the panel thickness, line speed, basically the output of the PU. And then again, have to check the air nucleation, the air percentage, if it is correctly adjusted. Coil oblique metal sheet shifting. So this happens related to the tie part. So the metal sheet gets shifted towards any of the end. So in this case, has to check the roll formers settings with the roller, the filler gauge. Have to check the ribbing roller settings also. If it is pressing too much, also it will reflect into the coil shifting. Also, I have to check the alignment of roll formers. If it is cassette type, then if it is aligning properly with the railings. Uneven thickness of the panel. So for this, I have to check uniform lifting of the DBL. So sometimes happens that if it is double belt, some of the cylinders are having malfunction. The lifting is not uniform, and that reflects into the uneven thicknesses. Have to check the hydraulic pressure, whether it's correct or proper pressure is there, and have to use the proper spacer if it is hydraulic type. Some important safety briefings onto the blowing agent. So since continuous line majority the pentane is being used, so which is the explosive chemical. So basically the any explosive chemicals or what if you these are the three major sources can cause the fire, like physical leakage of the chemical, the presence of oxygen, and the presence of static charges or any flame. So these three things are coming together, then this will result into fire. So to eliminate this, we have to avoid either all three of the things or as much as possible from all these three. So for this, have to use the gas sensors to detect the presence of the pentane in a gas form. Then have to use exhaust ducting to extract out the gases at the forming area at the chemical mixing or pre-mixing area. Then next is how to use the nitrogen gas blanketing at the pentane storage tanks, whether it's above ground or whether it's underground. So nitrogen blanketing will eliminate the presence of oxygen. Also, it can be used for the discontinuous panel as well. Before injecting the PU, nitrogen can be injected into the cavity to eliminate the oxygen. The equipment has to do the earthing properly, and all this foaming area or the pentane area has to avoid the naked flames, especially the smoking, weldings. Yeah. So these are the some safety precautions. So now we can open for the question and answer session. Thanks. So we can, if you have some doubts, we can discuss on that. Thank you.
Hello. So the questions can be asked now. Please unmute yourself and ask the questions. Hello.
Hello. Good afternoon.
Hi, good afternoon.
My name is Suhas. I'm in Dubai. I just wanted to know about tilting process. What you have mentioned about removal of the air entrapment. Can you throw some light on that?
Yeah. Basically, in a discontinuous press or any foaming process, if you can see, if you have the tilting mechanism where you're injecting the PU, be it like a rigid foam or be it a flexible foam, if it is having tilting and you inject, so when the foam started rising from the bottom to the highest area, it will purge out the air. It will push the air out. So the similar principle is here. The press is tilted opposite to the foaming or injection port. So before injection happens, the press is tilted at around 20 degree or 30 degree, and then the injection happens. So the foam reaches to the bottom part first, and from there it starts rising. So when it starts rising, it pushed the air out. So it is basically helping to faster air escape.
So, are you providing any venting system, a specialized venting system to take out the air? Because most of them are having the bubbles when the panels comes out of the press. This is what is observed here or everywhere in the world. So I just wanted to know, or can you share your email ID so that I can talk to you or your contact details, because I've got a lot of questions and I don't want so many other. Okay, thank you. I will take the photo of that.
Yeah. So
Okay.
yeah, you can reach to us and we can give you some more information on that. Regarding your question of whether we do provide air vent mechanism or something, the answer is we can say it's not we supplied, but basically this is a part of process. The air vent holes basically are onto the side molds. Yeah. So side molds customers prepare based on their number of thicknesses, and these air vents hole they have to put it onto the side molds. So number of holes and the frequent cleaning of those side the air vent holes is necessity.
And my last question will be, last question will be, do you have the flat lamination process? Which also.
Then
No, please go ahead.
flat lamination is a combination of like a discontinuous and the continuation, right? It is, yeah. No, as of now we don't have. Yeah.
Okay, thank you.
Yeah, thank you.
Okay, so do we have any other question? Hello, anyone has any other question?
I am Karthik from Amantir, Chennai. Yeah. So I have a question. So you you mentioned about that corona treatment, right? Corona. So
Yeah.
can you explain that one? Because for the metal additions, most of the time customers are telling about this challenge, the addition issues. So you're talking about something that in that line. Can you explain that?
Okay. So the Corona unit basically is I show you the photo. Yeah, so you can see here there's a Corona unit photo. There are basically two rollers which is having the there is a electrical system inside. So when the sheet goes through these rollers, the first thing is the static charges being removed electrically. Second thing, actually, if there is a fine dirt or oil stains are there, that's also get removed, and there is a exhaust ducts available here, so which extract out that dirt from the sheet, and it's being collected at the outer section. So this unit can be installed onto the existing lines if the existing lines don't have this unit, because this is individually comes, and there is no relation between the line speed and all. There is no especially any integration as such or interfacing required. This can be separately installed as well.
Thank you.
Yeah. Thank you. Thanks.
Hello,
Yes, sir.
this is Devalan. Ashokji,
Hi. Yeah. Yes, sir. Yes. Tell me.
good evening. Your presentation is very good.
Thanks.
I have only one question. I am not understand this nitrogen something. You informed that last point.
Mhm.
Oxygen, some mixing, something is there. I am
Right.
not catching.
Blanketing.
Yeah, nitrogen blanketing. This is a part of a safety system.
Yes, blanketing. What
Correct.
is that?
Okay, so for example, let's imagine if you have the a pentane storage in a day tank, or you have the pentane storage in an underground storage tank. So nitrogen blanketing means that on the storage tank, you cannot fill 100% with the pentane. As per the regulation, you can say, or as per the safety standards, you have to keep the 20% space empty in the tank. So that 20% space, you have to use the nitrogen inside the tank to pressurize it. So it works in a two way. One thing is, when you use the nitrogen inside the tank for the pressurization, it helps like it's a kind of blanketing, meaning that it removes the oxygen from there. Okay. And second purpose is this nitrogen pressurization also helps to push the chemical to your metering pump. So that's
Right.
helps for the positive suction pressure.
Okay. Now I understand that one. Yes.
Okay.
Thank you.
Yeah.
Thank you.
Thanks. Yes.
Okay, so if there are no more questions, let us thank Mr. Ashok Kandalkar. Thank you for this well-articulated presentation, sir.
Thanks, madam. Thanks everyone for your time given for this webinar, and thanks IPU for giving me this opportunity. Yeah.
Thank you so much.
Yeah. Thank you. Thanks.
Bye bye. Bye bye.
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 Thanks. Bye.